Hello everyone, welcome to the YouTube channel Learning Videos. So in this video tutorial, today we are going to see the code for Taylor and Maclaurin series using differentiation method. Now, this is the second program in mathematics lab prescribed by BTU. First, we will check the manual calculation, then we'll move on to the code. So this is the expression for Taylor series formula. That is f of x equal to f of a plus x minus a into f dash of a, x minus a square divided by 2 factorial into f double dash of a, and so on. So now the expression that we have taken for calculation, f of x is e raised to x into sine of x. Now here f dash of x is nothing but differentiation of the function once. F double dash is differentiation of function twice. F triple dash is differentiation of the function thrice, and so on. Now, after this, the value of a will be given to you. So here we will consider a as 0. So if it is given some other numerical value, you have to just insert over here. Next, we will see the Maclaurin's series formula. It's a special case in Taylor's series. So now here what we are doing is we are substituting the value of a as 0. Okay, we will substitute value of a as 0. So you can see over here f of a is 0, and this will turn out to be x into f dash of a, and so on. Now we'll calculate the differentiation of it and we'll substitute the value, and at the last we are getting this value. Final Maclaurin's expansion, we are getting it as something like this, up to 5 terms. Okay, it can go on till many values, but we are limiting it to 5 terms. Now let us check the code. We are importing a package called as SymPy and we are calling it as SP. Now we are declaring the variable, that is x should be treated as symbol. Now we have function f of x, we are declaring it over here. It is nothing but e raised to x. So that is why sp dot exp x into sp dot sine of x. Okay, so the expression is e raised to x into sine of x. Right? Now, number of terms that we are going to do till the Maclaurin series or Taylor series is 6. Next, we are defining the variable as a, that is sp dot symbol comma a. Okay, so this line of code you can include in this only. It will be more convenient for you to write the code. Next, we have declaring a variable called as Taylor, and we are calculating sum of it. Okay. Now, how we are calculating sum of it? Just check over here. Sp dot differentiation. So, as we have said in the base formula, that we need to calculate the differentiation. You can see over here we need to calculate the differentiation. For that, there is a method called as sp dot diff. Okay. So now sp dot diff I'm calling. I'm passing the function called as f. What is f? F is nothing but e raised to x into sine of x that we have passed over here, comma. I'm differentiating it with respect to what? I'm differentiating it with respect to x. Okay. Now, I. What is this I? I is nothing but, as you can see in the general formula, we have f dash, f double dash. That means we need to differentiate it once, we need to differentiate it twice, thrice, and so on. So, here comma I will represent that. So I'll rephrase this once again. So here sp dot diff will differentiate the function f with respect to x, and I means number of times. Okay. And then I'm calling a method called as subs. So now if you have seen the previous video, I have said what is subs will do. Subs will substitute the value of x and a divided by. So you can see here sp dot factorial of I. So check the base code. What does it says? Divided by factorial of I. If it is 1 factorial here, if you write 1 factorial, it is no issues, because 1 factorial means 1. So 2 factorial. So if it divided by I, that is sp dot factorial of I. If it is 1, then 1 factorial. If it is 2, then 2 factorial, and so on. Into, you can see here, into this we have calculated now, f dash of a, and 2 factorial also we have calculated. Now we need to calculate this x minus a, the whole square, whole cube, and go, and so on. So now minus x minus a, star means, as we have already said, what is star? Star means raised to. Okay, raised to. As you can see over here in our general formula, we have raised to 2, raised to 3, and raised to m. Okay, and here x minus a raised to 1. So what we will do is we will write star star a, sorry, star star I for I in the range n. So now why we have written this? We have written this for the reason that this block of code should run from I to how many number of times? 6 number of times. Okay, from here it should run till 6 number of times. That is why we have given for I in the range n. Range n means it will run 6 number of times. Okay. Next, in Maclaurin series, as I have said, the Taylor series will substitute the value of a as 0. So we'll substitute over here, that is comma a as 0. Next, here this is directly a simple print statement that we are printing over here. Okay. Next, again Taylor series, a simple statement that we are printing over here. And next, I'm printing sp dot a simplified version of Taylor series. Okay, simplified version of sp dot simplify Taylor. So what is Taylor? So this value I'm going to simplify. Okay. Next, I'm simplifying the Maclaurin series also, sp dot simplify Maclaurin. So this value that which I have substituted, I'm going to simplify. Okay. This is the output for your Taylor series and the Maclaurin series. Okay. So that's it for today, guys. If you have any query regarding this, so you can comment me in the comment section. I'll definitely try to help you on it. We'll meet in the next learning video. Till then, keep learning and keep growing.